Okay, here's our first word problem. So the question is asking how far does the student jog? So we're gonna, hang on one second. Is this the one that we did in class? That's the one that we did in class. So I'm gonna scroll up and start with number 2. There we go. So one solution is 50% alcohol, the second is 70%. How much should a bartender mix in order to make a 30-liter solution that is 55% alcohol? So we haven't really assigned anything in terms of the solution, so we'll call solution A. I'm going to move this over a little bit. So we've got solution A and solution B. And so on this side, I'm going to put volume. And here are percent. So it's gonna, this bartender's gonna mix, how much should a bartender mix in order to make a 30-liter solution? So we have no idea how much of each solution is gonna be used. So we'll call solution A X, solution Y, solution B we'll call Y, and the total will be 30. The percent of solution A, let's call solution A the first one, is 50%. And second solution, solution B, we'll call 70%. We want the final total to be 55% alcohol. So if you haven't done so, see if you can set up your equations. Pause the video, and then I'll put the equations together, and then you can check to see if you're correct. So setting this up, 50% of X, 70% of Y will equal 55% of 30 liters. So the two equations look like this. I'm going to pause the video again and you solve for X and Y. I'm not going to show all of this just for expediency here. I'm just going to put up the solutions for X and Y and you can check that you've done them correctly. Okay, so I've got, when I solve this for X and Y, I end up with X equals 22.5 liters and Y equals 7.5 liters. So again, make sure that you're doing a check, right? So always make sure you substitute back in to make sure that it works in one of the equations. And also don't forget a statement, right? Each of those worth marks. So you got to remember those things. Okay, second question. 508 people at a sheepdog concert. Yeah, check them out on YouTube. They're good. The good seats cost $45 each, but the balcony was only $28 per seat. The total revenue for the concert was $19,035. So how many of each ticket were sold? So again, pause the video if you want. Do that right now, but I'll keep going. So we're going to let I don't know, let's call it the good seats. So let G equal number of good seats. Let's let B equal the number of balcony seats. And so if we set up our table, we've got good seats. Let's go like so. So we got good seats. We got balcony. And we've got total. So here in our first column, or first row, sorry, we're going to have total number or number. So good seats we don't know. We're going to call that G. Balcony we're going to call B. But it said that they sold a total of 508. And here we have the cost per seat. So we had $45 for the good seats. We had $28 for the balcony and the total revenue generated was $19,035. But keep in mind, the cost here is 45 times the number of seats that we sold and 28 times the number of the balcony seats sold. So again, if you haven't got that figured out or the equations, maybe pause it, see if you can come up with the equations. I'll keep going. So equation 1 is good plus balcony equals 508. And then we have 45G plus 28B equals 19,035. It's equation 2. So I'll put the answers up, pause the video, see if you can find that solution. Okay, if you solve those equations, I get the balcony is going to sell 225 seats, and the good floor seats, they sold 283 seats. Okay, moving on. I like this one. I made this one myself, following the modern times. A producer of medicinal cannabis wants to create a mixture of 2 of her strains for sale. Strain A sells for $13.50 per gram and strain B sells for $10.80 per gram. How much of each should she mix to create a 500 gram stock that will cost $11.75? So pause your video. This time I'm going to pause the whole video. I'm going to set up the solution. I'll set up the table and you can restart. So if you've set up the table, I said let A equal the grams of strain A, B equal the grams of strain B. So across the top I've got strain A, strain B in total. Grams of strain A is A, grams of strain B is B, and that should total 500. I'm going to write the equations here down as we go. If you want to try that on your own, then pause the video. Equation 1, A plus B equals 500. Equation 2, 1350 plus 1080 equals 1175. And again, sorry, 1350A, sorry about that, plus 1080B. Okay, pause the video if you want to determine A and B. Just a word of advice. I believe elimination is the best method. When you have something like this, you can easily multiply the top by negative 1350 and add them, but you can use any method, right? So pause the video and solve for A and B. Okay, that's what happens when you try to make up these questions too fast, or if you're smoking cannabis while you try to make up these questions. And you might have seen that I made a mistake here. This dollar figure should have been the total cost of this 500 gram stock, which is 5,875 is what that whole 500 gram stock would sell for. Hey, it's a half a kilo. It's going to cost, that's pretty reasonable, 6 grand. Anyhow, so sorry about that. In looking at that, this should have been 5,875. So hopefully if you didn't waste too much time wondering what you did wrong, try and solve that system of equations and I'll put the answers up. So I ended up with, we round up a little bit here to make whole numbers. So B equals 324 grams and A is going to be 176 grams. I think now I've done this really quick, so if I screwed up and made a mistake, I wouldn't be surprised. But that's what I got for A and B. So I do realize number 5 is a very similar problem. So I'm going to go on to number 6 because I'm running out of time a little bit and I have to get going. So number 6, if you want to try this one, a car travels from one town to another at a speed of 32 miles per hour. If it had gone 4 miles per hour faster, the trip would take a half hour less time. How far apart are the towns? Okay, so try and set up your table. I'll pause the video And then once you feel like you got the table set up, restart the video to check your table with my table. Okay, so we want to figure out how far apart the towns are. And so what I'm thinking of is we know the speed, the slow speed, traveling at 32 miles per hour. And if it had gone 4 miles faster, the trip would have taken a half hour less. So I set it up as the slow version of the trip and the fast version of the trip. So the rate of the slow was 32 miles per hour. The rate of the fast is 4 miles an hour faster. So we know those to be true. If it had gone, the person had gone 4 miles per hour faster, the trip would take a half hour less time. So we don't know how long the time took, so I call let t equals the time it takes. So the time of the slow trip is t, the time for the faster trip is t minus a half hour less time. Formula distance equals rate times time, so therefore distance is 32 times time, or 36 times time minus a half. And since it's the same trip, just going faster, then those two things are equal. 32t equals 36t minus a half, and we can solve for t. So if you want to pause the video, go ahead, and I'll finish to solve it here. So 32t equals 36t minus 18. So we subtract 36 from this side, subtract 36 from this side, and we get negative 4t equals a negative 18. Divide by negative 4, divide by negative 4. So t equals, so that goes in there 4 times and 2 left over, or 4.5 hours. So now we have to find how far apart are the towns. So we've just found the time it takes, distance. So if I take 32 times 4.5 hours, then punch that into my calculator, 32 times 4.5, and I get 144 miles apart. Or sorry, yeah, I guess the traveling from one town to another. So the distance the car had to travel was 144 miles, or the towns are 144 miles apart. Okay, I hope those help. Have a good rest of the weekend.